Okay, so using synthetic division, I had a 6, 25, 74, and then a 248 as the number in the bottom house. So when I rewrite this polynomial, it's the divisor, x minus 3, times the quotient. If this was x to the third, this is 6x squared plus 25x plus 74, and then I have to write the remainder. So neither one of those are actually factors. For the second one, I had to put the two zeros, so I end up multiplying through, and I do actually get a 0 here. So I have x plus 8 times, that's 1x to the second, drop that down 1x to the second, minus 8x plus 64. Okay, moving on to another big theorem here. Seeing as how the remainder theorem tells us that the remainder when dividing by x minus a is actually f of a, synthetic division can help you find a y value for an x in a polynomial faster than actual substitution. So I can put in an x and get a y faster than actually putting in an x to get a y. That's what I'm saying. The remainder theorem in synthetic division can help us out with that. Find a f of 3. So look, I'm going to put 3 in the house. I go 1, negative 5, hang on, x to the 4, x to the 3, x to the 2, x. We're missing a term, so I'm going to need a 0 at the end of that. Be careful. 1, negative 5, 2, 8, and 0. So instead of putting in a 3 and going 3 to the 4th, 3 to the 3rd, 3 squared, 3, I'm just going to do this. Bring down the 1, multiply, you get a 3. Add these, you get negative 2. Multiply, you get negative 6. Add those, you get negative 4. Multiply, you get negative 12. Add these, you get negative 4. Multiply, you get negative 12. And I get negative 12. What that means is f of 3 is negative 12. There's this point on the graph. Why don't you guys do the next one?